Hello everyone. So let's take our second question, that is recover binary search tree. Okay, let's see what the question is. You are given the root. Okay, there's a root, and where exactly two nodes of the tree were swapped by mistake. Okay, so it is a BST, and two of them are swapped. Okay, recover the tree without changing its structure. So we have to return tree. Yeah, we have to change the tree, modify the tree in place. Okay, so what we can do is without changing its structure. So we have to swap those two values, whichever we found. Okay, and are they unique or not? Yeah, it's BST, so they must be unique or okay, they are unique, I guess. Um, Follow-up is using order of n space is pretty straightforward. Could you devise a okay, yeah. So yeah, it's like true. Order of n space is what? Like we have a tree, then suppose this is a tree. If this and this both nodes are swapped, just use an in order traversal because it is BST, and like we let's suppose in order traversal we found is 1 2 3 and 4 and 5, or rather say 1 2 4 3 and 5. So these two nodes must be swapped. Okay, so it's like that. So we found that where if an element is greater less than the next element, then that is our answer, the first node. For second we will say if the second node is okay, if this is near 4, so yeah, we will find a node which is less than the previous node, so this is the one. Okay, yeah, it makes sense. So 4 and 3 will be swapped. So okay, it will be in order of n space because we are storing this array. So to do this in order of one space, let's directly jump to the order of one space solution. Okay. Or should we do in order? Let's first do order of one, then we will do in order. Okay, in order of one. Best one at first. So we are at here. We will go left and right. Let's suppose we are doing in order traversal. Okay. So for each route, or we will do any traversal. Let's do any traversal. Or in order traversal will be okay. So when we are at any route, we have to check whether its left, its left is there, if its right is there, or above it. T values. Uh, okay. No, no, no. Rather than what we can do, we will take three variables: first, second, and third. Okay. This will store three nodes in consecutive. So at any point of time, suppose this is our an array. Okay. This is in order traversal. So at any point of time, we are gonna use these three nodes. Okay. Then this will be a sliding window type. And then the next will be like this, these three nodes. The next will be like this, and same as that. So using sliding window, we are not storing the whole array. Instead, we are taking first three integers. But how will we manipulate it? So whenever we are appending a new one, then we are gonna manipulate it. Okay, we are. Yeah. So let's try it. So let's suppose we have first, sec, third key values, and okay, these can go to -2. Okay. So let's update it as float of infinity. Okay, we can directly do a tree traversal also. but then we have to store left, right, and sometimes a parent. Okay, that will be a bit messy, but we can also do that. Okay. l- This is a fine approach using sliding window type of thing, but let's do another. So we are traversing in an in order fashion. Okay. Oh no, we have to store parent then. No, it's rather it would be a better approach. Storing parent will again become order of n space. Float of infinity and float of infinity. Initially all are infinity. So okay, let's take define in order and pass root. Okay, if not root, then return. Else, in order on root dot left, root dot val is our current node. Then we are gonna use in order root dot right. So at the point of time we are using root dot val, let's store it inside a okay. Instead of it, let's check for first, second, and third. So when we are here, what we can do is can make our second as root dot val. Okay. We have to also make it as done local inside done local first, second, third. Now if let's yeah, we updated second is equal to root dot val or second is equal to third. Okay, then will become third. Before that, first will become second, second become third, and third will be our root dot val. Okay, this happened. Okay, but before this, we will have a condition, that is if first okay, if yeah, this way we will able to travel till last. Third is becoming root dot val. Okay, it's okay, but we have to put condition like if first is equal to okay, if first not, if third is equal to float of infinity, third is equal to float of infinity, mm, float of infinity. Okay, then we have to exactly make our third. Okay, no, if third is float of infinity, then just make our first as okay, read of first. Let's it's like a pointer. So basically what we are doing, suppose our in order is 1 2 3 4 7 and 5, something like this. So this is initially this will be our third. Okay, this will be our third, then this third will become this and second will become this, yeah, something like this. So initially if third is float of infinity, make third as uh, point third to as root dot, make third as root dot val. Okay, elif if third is not float of infinity, if second is float of infinity, float of infinity, then that means third is not float of infinity. So second will become third and third will become root dot val. Okay, third is always becoming root dot val. Yeah, so we don't need to add it. Okay, let's, and the last one is elif first is equal to float of infinity, not last, this is second last. So if first is float of infinity, make first is equal to second. Okay, we don't need to do this. Yeah, if whether it is float of infinity or not, it will become like this. Okay, else first will become second, second will become third, third will become root dot val, and first will disappear. So third is becoming root dot val in every case. Okay, second is equal to third, but before that we need to do second is equal to third. Okay, so if this is something like this, if this is, then pass, or third is equal to root dot val, first equals to second, second and third will become root dot val. It's like this. So yeah, it's done, and we will reach at the end. And after this, if okay, so let's take an example. Okay, solving it in after one. Okay, that's something. Take an example. 1 2 3 sorry, 7 5 6 2 1 3, and this is like 15 12 17 16 20. Okay, now let's take all the cases. If swapping happened in between, okay, so 17 and 5 are swapped. So here now the new value is 17 in here, and the new value here is 5. So we have to check whether an element is less than the next element. Okay, initially let's suppose, okay, yeah, so we every time we will have 3 nodes. Okay, so third will be pointing to it, then third at last will be pointing to it, first to last. So yeah, so we have to take a condition that if first is not equal to float of infinity, first is not equal to float of infinity. Okay, first is not equal to float of infinity, then we have all three, first, second and third. So swapped node, okay, swapped node is equal to something like this. So if first is not equal to infinity, then we have to check that okay, what we have to check, first is not equal to float of infinity, then okay, if first is greater than second, yeah, at any point, if our first is greater than second, here if second is greater than third could also happen, like 16 17 and 20, but we are checking first is greater than second. Okay, then result dot append first, yeah, first. We have found our first index. Okay, L, if second is okay, if first is greater than second, you have to take it wisely, like 1 is there, 2 is there, 5 is there. So first will be 1. Do we need 3 pointers? Rather we can make use of 2 pointers already, but still let's take 3 pointers. Okay, so when we are at last at the end, we have first, second, and third. Okay. And in the end, we will have our second and third also. Like these are non-local variables, these will store the value. So we only need to check first and second. If first and is greater than second, okay, yeah, first is greater than second every time. If first is greater than second, like 17 is greater than 6, then one of the solution will be res dot append first. Okay, it's done. Now, if if not res, like if res, if it has already appended till now, yeah, it means that if we have found our first and second, then what should we do? If this is like suppose we have found that this is first and this is second, then in this scenario, first is this, second is this, and third is this. Now we have to find the next swapped node. So yeah, res is equal to, why am I using res? Sorry, should be swap node. Swap node control V dot add control V if swapped node. Okay, swap node is there. Then if swapped node, yeah. So we have already found 17. Now we have 5 in here. So if at any instance if second is greater than third, or no, rather second is less than first. This is our second, this is our first. Okay, second is less than first. Yeah, we have to use same thing. If swapped node, then okay, so we have to add one more thing here. If not control V and okay, I guess I'm doing wrong. If first is greater than second, so it is going to happen 2 times in the whole array. So if first is greater than second, then swap node dot add first. Okay, so we are adding every time. Okay, set. Okay. Yeah, this will add all of them, and when it will get out of it, we are left with a second and a third. Okay, after that, if second is okay, 1 second, if second is greater than third, uh, at first let me make it a hash set. So if second is greater than third, yeah, if at the end if second is greater than third, then append this also, like add this also, dot add second. Second is greater than, then add third, sorry. Yeah, okay, then call in order, traversal in order on root. Let's see how much time passed. Okay, it's already 19 minutes. In order on root, and okay, at the end we have to check if fab node length, if length of fab node second, we are adding third here. If length of swap node is equal to 0, no, is equal to 2, let us suppose. Okay, return, yeah, and update 3. Okay. Then update, put root inside it, and update root comma swap node. node 0 comma swapped node 1. Yeah, else, yeah, okay, okay, it's, you have to return none. So return else. If this is not the case, then the, okay, if this is not the case, okay, there can be cases also, like suppose if instead of swapping these two, let's swap these two, okay, this will become 2, this will become 1. So there's only it happens only once, it happens only once in a while that 2 is greater than 1. Okay, yeah. So if there's only one node we found, then its next will be our answer also. If 2 is greater than 1, traverse everything. If 3, then it is in sorted order. Or let's suppose 20 is here and 17 is here. So 20 is greater than 17 and everything is, rest of everything is like simplifying. So in that case, length of swap node will become 1. Then we have to update. So swap node and okay, so swap node will be first. Um, temp, temp, a variable temp temp like if length 1. Let's suppose if one node found, one node, if one found, okay, let's make it as -1, something like that. Now if one found will become, if we found that, where are we finding it? Yeah, if not first, no, if first is greater than second, this. Yeah, so if first is greater than second, add first and add second, this will become our second. Yeah, so we are going to pass the 0th one, and if this will work, and convert our, okay, and also convert our swap node into list is equal to list of is equal to, didn't work. This will work. And before it, before all of it, can the node and the root, okay, number of nodes in the tree is in range 2, it can be 2. So for 2 we have to separately find the solution. So if, okay, how could we find it? Let's check whether it is taking care of it or not. No, it is not. So if it is the case, then second is this, and then, okay, if third is equal to float of infinity, pass. Third will be float of infinity always in the at the first thing. Okay. If second is equal to float of infinity, if third is equal to float of infinity, yeah, third is equal to root dot 12. Third will become root dot 12. Yeah, so second and third are there when nodes. Okay. Second and third contain node value. So even after all this, if first if first dot val, yeah, no, if first is not is equal to float of infinity after all of these, then we know it implies only two nodes in tree. Only two nodes in tree. So in this case, we are gonna do second and third. So second and third will be updated one. So let's update root, sec and third. It will work and return. Now we have to write this update function. Okay. So let's write it. Okay, let's write it at the define update. And let's suppose the root is there and there are two values a and b. So if we found a, then convert into b. If we found b, then convert into a. So if not root, then return. Else root dot val, then update, and simply do an in order. I will gonna do simply an in order on root comma root dot left at first a then b. Simply okay, yeah, this is fine. Let's do another in order. Control V on right, and let's change root dot val is equal to no if root dot val if root dot val is equal to a, then convert root dot val is equal to b. If root dot a is converted into b, we won't come up here again here. And if root dot val is equal to b, then make root dot val is equal to a. Yeah, it looks fine. So let's run the code and see. Yeah, it was long. Wrong answer even after 27 minutes. Output is 13 null 2. So it changed 13 null 2. Let's print our swap node first. Print swap node 13 null 2. 132. So remained same. Why swap node is not print? Because first is infinity still okay. First is still infinity or what? Like print first, second, and third. Okay, I have to. Okay, it is still haven't changed after all of this. Yeah, all of them are infinity. So I have called in order on root dot right. Okay, I haven't called. Yeah, 1 second. So I have called in order after it. Sorry. So I have to call in order at first now. Okay, its sequence was a bit messy. This video is going to be long. Okay, 1 and 3. Yeah, okay. This is the problem. Like we have to swap it, and while swapping it, we have to flag it that okay. So, oh, sorry, we have to use elif. My bad. If this is the case, do this or this. Yeah, accepted. Let's remove our print. This question can be done in order of n space, and it would be like very simple. It won't go like this long. But the real challenge was here. Okay, so it's giving a wrong answer. Yeah, it if one found is still -1, that's why it is giving wrong answer. Oh, I haven't. If one found, I have to make it non-local now. Is a non-local variable. Cool. Now it will work. And I get a lot of errors. Let's submit. Still I'm printing something like it is printing Hey, 3 1 2. So 3 1 and 2 1 3 and 2. Okay, 3 out is 2. So it didn't reach here. In order, it has no second. I have to deal with it. Okay. Expected is 213 and I am returning 3 1 minus 1. So this one is not changed and I am passing -1 to it. And swap node is only 2. 3 1 and 2. 1 3 2. So it should also put 3 inside it. But as you see that it is not, then let's see where the problem is. So it is calling. Oh, because of this part, I guess. Only 1 second. Pass or what? What I have to do here? Um, yeah, let's do pass. So if one found is second, then fab node 1 second. Let's print it to make sure whether we are committing any mistake or not. E 1 minute, bro. 1 3 2 and -1. Okay, 1 3 and 2. These all are okay, but if one found is not updated, what's the case? Why it is not updated? Okay, here it should be updated. Let's do something else here, like ph is equal to 9. There's problem in my code. So if first is greater than second, the app node will dot add first. Okay, if first is not equal to float or infinity, then only it is going to be inside it. So if first is greater than second, 3 1 2, 3 is greater than 2, let's print it. Let's print our first, second, and if we found. Print first and second. Okay, after coming from it, like first is not equal to infinity, it will happen only once, and it is only checking about 3 and 1. It doesn't. Okay, sorry. So after this, let's see the details first. Yeah, 1052 test cases passed. Yeah, this one will also pass. The thing is, what I'm doing wrong is, so when the second is greater than third, I have updated this. Okay, but what if length of swap node, okay, whether length of swap node is like this or not. 1 second. Length of swap node, yeah. If length of swap node is still 1, okay, then if 1, sorry, if 1, yeah, if 1 found, if make if 1 found is equal to 1 second, if 1 found will become, I'm adding third. So if 1 found, if I'm adding third, I'm adding third. 1 second. So 3 1 2 is there. Okay, if second is greater than third, 3 1 2, 3 is greater than 2, and I have added I think third. 3 is greater than 2. Yeah, third is added, but second is not added. Yeah. 3, 1, 2. Like this tree is here 3, 1, and 2. Okay, 2 is added, but this is not added. The second is greater than, if second is greater than third, then add third and also add second too. Yeah. Now second is updated. It will get accepted. Now let's run our code. Oh man, again problem. 14671 is okay. Minus 13. It is returning same thing. It is not 231. 321 and 231 are 321. Instead of swapping these two, it had swapped these two. Well, see, 1200 one test cases passed. It's like a milestone. Why it is for. Let's create this tree to see where are we doing wrong. So 146, 71, then minus 13, 146, 71 minus 13, 35. This is null. This will become 231, 399, 321. This is null. Okay. This is null. Everything is null. Let's use tree visualizer once. Where is this minus 33? Okay, minus 33 is in the end. This is minus 33. Now let's go. So what we are doing, have first, second, okay, print our first, second, third every time, or print our swap. Okay. So minus 13 is greater than this. What? Minus 13, 55. Is it even a BST? 146, then if it will get, let's replace this with 321. Okay. This is a set. 321. What am I printing? First, second, third, and if one found. If one found is minus 13. Okay. Swap node is adding. Swap node is 321 and 231. And the result is 321 minus 13, 231. Like, why there are three values? Minus 13 is here. It got swapped with this. Sorry, I have to compare between these now. Minus 13 to the minus 13 and 321 are swapped. Okay. Minus 13, yeah, this should be swapped 321. And what am I doing is I'm finding an integer which is greater than the next one. So it will give me this. And the next time what I'm doing is an integer, okay, which is less than the previous one. So minus 13 is less than 231. So we have to, instead of taking minus 13, okay, minus 13, 321. Minus 13, instead of taking minus 13, I took 231, I guess. What I have to do is, if this is greater than this, then take 231 or what? Oh yeah, 40 minutes. So if first is greater than second, in this case, if first is greater than second, what am I doing is, I'm adding first. So here 321 is greater than 55, I'm taking 321, it's okay. But here I am at 231 is greater than minus 13, I should take second. Hmm. So if I don't know how these much test cases pass, if this the logic was flawed. I make a taken here. If swap node, if not swap node, and first is greater than sec, then swap node dot add first. Okay. Elif swap node. Okay. And first is greater than sec, and add sec inside it. Swap node dot add sec. What accepted? 1 second. Let's check on something else too. Like we have, let's control Z it. We do have some input before this one. Control. Let's submit it then. Yeah, submit it. Okay, done. Thank you guys. Subscribe for more question. We will do more question of LeetCode. Okay, bye. Thank you.